I live now again?
Yes, you are live. Yeah, please, you can carry on. Thank you.
I've skipped the first slide because I already talked about it. I am not an industry expert in marine and maritime. I'm an industry expert in applications of metal 3D printing in medium and large applications. Okay. And anyways, in 30 minutes, only highlights can be done. I'm more involved in space technology, defense, and oil and gas for India and for US and for Dubai, and for large and ultra large metal additive manufacturing, for printing parts and repair MRO. I'm going to, whichever technology I talk about will be directed energy deposition. Okay. My intent in this talk is to provide insights into global trends in additive manufacturing, the key technologies, some business cases, and some good examples for you. And given that most of the audience is India-based or India origin, a snapshot of AM in India and the way forward. I think that will be useful for the entire community. And limited technical, this is not a technology presentation per se. I do 2-hour to full day seminars for companies that can be later. But above all, forgive my inconsistent formatting of the slides. I'm not an expert in PowerPoint presentation. I have no executive assistant at this time. And I have been involved in a very large project with DRDO, DRDL for printing fuel tanks for the Agni missile over the last 3 or 4 weeks. So I've had a very pressing time schedule. At the end of the presentation, I have many slides which I may not be able to share, but I can share with you, Shibu, and you can distribute to the key respondents. Okay. What is additive manufacturing? Simple. It is layer by layer manufacturing of a solid object. The diagram explains it to you. Additive manufacturing and 3D printing, in my mind, are except if you Google additive manufacturing, you may get 50 million results. If you Google 3D printing, you may get 500 million results. That is my only differentiation in this. Additive manufacturing is disruptive. It's a disruptive innovation. A disruptive innovation helps create a new market and a value network, and eventually goes on to disrupt an existing market and value network. Simple example, automobile was not a disruptive innovation, but the mass-produced automobile was a disruptive innovation. And I give you the chart on this. If you can see the trend in disruption, the horse transport had dropped to 0, and the automobile transport went to a very, very high number. That's all. So profound facts, simple facts, it is truly disruptive. It drives the fourth manufacturing revolution. It liberates manufacturing from limitations of conventional machining. It allows designers to think out of the box and do optimal designs. It is cutting years in product development cycles. It allows you to make parts that could not be possibly manufactured before. It impacts supply chain logistics and lead times. That is, I think, the most important thing in 3D printing and additive. In 5% a year. And my favorite phrase that I have used for 20 years, it allows just in time, just in place, and the optimal design. Summarizing this, it is here to stay. It is mainstream. It is strategic. It cannot be ignored. It will grow rapidly, and so many industrial applications coming up in this. I give you an example of supply chain. Everything is obvious, but the left slide probably is more interesting in maritime, because right now, 99%, 98% of manufacturing is distributed across the globe. And once it is made in country X, it is shipped to country Y via many channels. Is easily 90-95% of the shipping channels. That is a carbon footprint issue, by the way. And it also takes a long time. So many times the part that is made in China, for example, or Russia and shipped to Brazil, let us say, can take 2 months. When you can actually print on site in Brazil, if the digital file is sent to the printer in Brazil. Subtractive manufacturing has long lead times, high transport cost, high labor cost, and remote factories. It supplements my thing. And 3D printing takes it from idea to the end user right away. Right away. I mean, we're talking about the same day you can have it. That is the supply chain magic in 3D printing. I ran a video. Just watch the video for 2.5 minutes. Be patient. This is one of the state of the art. And this is what Bharat Fritz Werner and I am adopting also. Just watch the video. It is good. Where did it go? That's the problem with these things. This is hybrid manufacturing example, laser deposition and machining in the same machine. This is printing a certain part. This is printing a really amazing part, a sphere, basically. Pressure domes, oil and gas, marine, space technology, all applications. This is repairing a part using powder and laser deposition. Then machining it in a hybrid machine that BFW is introducing in the next month. This is printing some complex feature shaft, which in conventional manufacturing is not possible. You cannot do this, or it will take you days to do this. This is building a blade, basically, good for energy, but many applications, I guess, in marine and maritime. This is a hybrid application with coolant as machining and finishing the blade. Printing propellers. Giving you an example. I'll skip to the next slide now. This shows you what is possible. I wanted to show you the video. This is one of the key technologies applicable to marine and maritime and Navy. I include Navy in the whole thing because that is also marine and maritime, in my opinion. It goes on the ocean. These were time-lapse videos, but none of the videos of a printing process that was longer than 70 or 80 hours. And those parts would take months to make conventionally. Okay? You can print parts, you can repair parts, you can flat parts, you have hybrid processes, you have robotic and gantry implementations, mobile systems, and retrofit on existing machines. And this is 5 to 7 axis real-time printing and motion control. And I want you to all think about the possibilities. That's why I showed you the video in the beginning. The current trends of metal additive manufacturing. I'm not going to talk about plastic. For me, that is yesterday. And it's very low value. There are some applications, but in marine and maritime, certainly very, very few that have value. However, marine and maritime has lagged the industry, perhaps because of the size of the parts. The leading industry adoption today, I'm talking about last month, space technology is number one now, absolutely number one. Then spare parts and supply chain reduction is number two. Digital inventory. Lot of large-scale industries basically keep a long inventory because it takes too long to get the parts. So digital inventory means you keep the digital file and then you print it on demand. That is a massive cash and time improvement. Defense easily is in the top three. Air Force, missiles, other weapon systems, land, army, navy, and between number 1 and 3 are my subject matter expertise today for India and for overseas. Then oil and gas and energy, die and mold tooling, medical is very, very big and growing even faster, but it's still a small industry because the parts don't cost as much. Automotive, yes, I'm not into automotive. Number 8 comes marine and maritime, in my opinion. Okay, it should escalate to at least number 3 or 4. Higher than that, it may never go because some of those other technologies are massive valuations. Then you have commercial aviation, lot of certification issues, prototyping, everyone does it. Then research, nuclear waste disposal is huge, but I have 2 applications I did in US. I cannot talk about those. As a US citizen, I'm not allowed to talk about those nuclear applications. Fundamentally, for marine, maritime, and naval applications, the vast majority are in metal parts and metal part subsystems. Most of the high-value parts are too heavy and too large. Such parts cannot come to the machine, so the machine must go to the part or be on board and in mobile configuration. That is happening more and more. Robotically mounted laser systems are becoming more common, especially in Northern Europe for some reason. I don't know why, but in Finland, Norway, Scandinavia, Holland, they're becoming more and more common. Directed energy deposition are the most suitable applications for such applications. I have definitions of all these technologies. End of the presentation, I may not be able to get to it. Repair, renovation, and surface engineering are by far the most important applications in marine and maritime. There are other powder bed fusion applications that are suitable, but they're going to be smaller and fewer in between. And plastic and polymer, I'm not interested. Why is my slide not moving? Alloys being used in marine and maritime, the most common ones. Nickel-based super alloys, by easily the most common. Superior corrosion and superior strength. They also cost more. Stainless steel alloys, they cost less. Corrosion resistance is not as good as nickel-based, but very good. And strength, of course, is there. Now, the upcoming applications, which are more and more, are tungsten carbide alloys in cobalt and nickel matrix, and stellites, which are cobalt alloys, for repair and surface cladding. Wear resistance, corrosion resistance, and increasing service life. Then the normal common steel alloys, 1040, 1030, blah, 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 where corrosion may not be a challenge in those applications. They're the cheapest alloys. Carbon fiber, I can't talk about. Titanium alloys are coming up, still emerging. They are lightweight, high strength, and no corrosion at all. So they're coming up and very high value applications. Some aluminum alloys, I'm not an expert in those. And then some exotic stuff, which no time to discuss them. Some fascinating innovation for in situ laser cladding for marine crankshaft renovation. That is a huge application. I have just cut and pasted from a great article. What it is it a laser cladding nozzle on a carriage, and it sits on the crankshaft journal and it deposits repair material on the crankshaft journal. That is absolutely incredible innovation. I love this. So I have included this in my presentation. The Navy, Naval and Seafair, they have a guidance document that keeps updated every year. And they have identified powder bed fusion, directed energy deposition for requirements in additive manufacturing. And some of the examples are there. Navy is going to be the biggest application in marine. I can tell you this now. Highest value, strategically important, by far. DC Marine, laser cladding. massive applications. In fact, the number one application in marine and maritime is cladding of shafts, propeller shafts, tubes. What is coming up? 3D printed submarines. This is an amazing application. You can just click those links and you can see what people are doing in 3D printed submarines. Okay. This is submersibles, titanium pressure vessels, and domes are becoming a key application in 3D printing. Okay. I won't discuss it in detail. I'm just showing you what has been printed. In fact, I was involved in printing this. $30,000 to $300,000 to $30,000, and the reduction in time 50% to 100%. 3D printed spare parts for nautical racing. This is amazing, but maybe not so good for maritime and marine, but for a lot of marine enthusiasts, this is a huge application. 3D boat propeller, it's all over the internet. I'm not very impressed with this technology, but they did a good job. You can do better printing of these propellers using laser and directed energy deposition. Might take longer, but much better finish and better strength. Anyways. US Navy will rely on 1,000 3D printed parts by end of 2018. However, by now, they got more than 5,000 parts going on. Lot of repair and printing parts of lot of different components. How do I turn this off? My God. DED applications in marine navy industry. This is some of the work I have done. Propeller shaft seals, steam system valve seats, stems, bodies and bonnets, submarine hull and backup valves, valve and machinery sealing surfaces, vent work for thin walled structures, machinery components, turbine blades, casings, pump housings, hatch covers, and certain weapon systems renovations, torpedo tubes, torpedo nose cones. Valve component examples. I'll keep it simple. So 1,700 man hours, 900 man hours, 800 man hours of repair. You can reduce those to 50 to 100 hours. Turbine inlet nozzles. They used to scrap 150 out of 400 in repair. Repairing with the laser deposition, you can repair them in a matter of hours only hours. Inner shells, ruptured materials, repairing these dents. Compressor housings, porosity issues, corrosion issues, wear grooves from turbine blades. They can repair them in hours. Making the business case, the metrics are, what are the pain points to solve? If you cannot save money or get advantage, then don't use it. Cost, lead time, quality, spare parts, inventory, new designs, rapid prototyping, lightweighting. These are all fundamental metrics. Most common metrics, reducing lead time and end-to-end cost. Okay? Example. This is for a fuel propellant tank for fuel for satellites. Lockheed Martin, end user slide. Titanium. Similar applications will be in marine, but I don't have any such applications in marine I can show you because I don't have that information. Starting from a titanium billets, 18 to 21 months for propellant tanks, $375,000 end user cost. 5 tanks a vehicle. With 3D printing with electron beam and wire in titanium, you reduce the cost by 55% and reduce the lead time by 66%. This is an end user example. This is not my example. Snapshot of current and future 3D printed industry from about, today it's about 18 billion today, 146 billion in 2030. I think it will be higher, but that is the forecast right now. So 11 times growth in the next 10 years. What industry grows 11 times in the next 10 years except for some silly hotel and scooter and retail stuff, which is useless for us. The industry projection by 2050 is between 1,000 billion and 2,000 billion. Marine maritime today is maybe 1 billion out of it, maybe 1 billion in 3D printing. It should grow to at least 10 to 20 billion. That is my vision. India, current forecast, 79 million, 80 million this year, which is correct. And it is only 0.4% of global 3D printed industry. I don't know how to shut this off, man. Let me.
But Ashok, your voice is still audible. You can continue as long as.
But I can't turn this voice off. It's crazy.
No,
You can once minimize this screen and then you
I'm
might
going
see
to
the
end this.
YouTube.
I can't deal with this kind of presentation.
No, minimize the
Way
screen.
forward
And
for
you can-
India in 3D printing. Strong investment and priority by government and private industry. Build world-class centers of excellence and training academies. Comprehensive education and training curriculums. Fund the leading and regional academic institutions. Encourage and support entrepreneurs with capital and opportunity. Focus on uplifting MSME segments especially. Provide facilities and funds for 3D printing. Government has done none of this. It is Indian government is not in the top 20. Make it a strategic initiative in government policies, especially in space and aviation. Intense campaigns for increasing awareness, business cases. Adopt proven successes from other people. Don't try to develop them yourself. People have already done it. This Make in India is a failure, but still try to leverage Make in India to the maximum. Don't reinvent the wheel. Learn, catch up, and then lead. I'm going to end this. I'll just end with BFW's initiative, committed to changing the game. It is offering any DED laser size machine, offering it 40 to 60% lower in final cost in India, guarantees spare parts and materials and applications in India, equal or better quality and warranty, and engage with the most premium applications in Indian defense, space and heavy industries, government and corporate, and be a national pride. Some examples of the BFW machines coming out, from laboratory size to ultra large metal DED 3D printing, fully industrial hardened gate, 5-axis, open and fully inert argon chambers, so you can process any material, available with robotic arm system, first and only in India. And let me go to the directed energy robotic system, and let me just say for marine, available in mobile systems where the metal printing system goes to the part for in situ applications, huge applications, marine maritime defense. Gantry based systems, just simply stated, you can put multiple laser heads to print clad long huge shafts, for example. Up to 7 axes available. Why we chose directed energy? This is an unmet need in India. Nobody is doing this. Very few companies. They all imported systems. You can process much bigger and much heavier parts. Surface and repair, surface engineering and repair, which is marine and maritime, huge application. Hybrid manufacturing, print and machine in the same machine. Multiple materials, functionally graded materials. And it leverages BFW's expertise in machine manufacturing, robotics, and multi-axis processing. I'm going to end my presentation right here. There's too much a distraction, but there is something at the end. Metal AM technologies that are TR7 or higher. Laser bed fusion, electron beam powder fusion. The 4 are the most to watch for, though. I say BHEL, but also marine, because there's a BHEL presentation slide. Directed energy with laser, with wire, electron beam, and wire arc. These are the 4 most to watch for. Cold spray and all are coming, but these 4 in blue are the most important to watch for. And some of the parts that are being manufactured in aviation and space, These are massive, 10-foot tall parts in multiple alloys, grid fins for rocket launchers, uh, divergents for exhaust nozzles for large rockets, and fuel tanks. Last slide. Construction, which is not of relevance, but this is a vision that I had in 2008. So I made this slide, and now you see you are printing skyscrapers in construction, especially in Dubai and the Middle East. And this slide means a lot to me because you turn off the printer, you will keep printing.
Thank you so much, Ashok. It was a fantastic presentation.
I'm done. Thank you very much. I'm logging off actually now.
Thank you, Ashok, for your very detailed presentation covering a very large area of technologies that has been in the offering, and also what you've been doing with DED in terms of what is expected for maritime and shipbuilding specifically, and a lot of good work that you've been doing in the aerospace already. So
Yes.
may I invite speakers to also share what they have to share, so that we can then go to the next speaker, or any Q&A or any questions. So it will be great. Let me also introduce Commodore Mr. Neeraj.
I had a question for the speaker, if you permit.
Yeah, sir. Please.
Sir, thank you very much for the nice presentation. We would like to get in touch with you separately, but most of the market in India for composites is now with North America, and both for the OEMs also. How do we bring in India the small and medium enterprise into this business? Because the market is very big, but controlled by big companies like Lockheed Martin Space. But India is a large market, but not yet realized the potential of this technology. What is your recommendation as far as composites? I was doing a white paper study. The fiber composites, which are the lightweight materials, will reduce the fuel consumption, will also reduce the carbon emission, and the overall carbon footprint will reduce. And the market is destined to touch to about $46 to $50 billion in the next 5 to 7 years, and North America is having 40% of this share. The CAGR is growing at 8 to 9% annually. Will continue to grow for the next 10 years. What are the three takeaways for Indian government enterprise to capture some part of this market? If you can do that, we can have a detailed discussion later. Yeah.
Is this a question for me?
Yes, sir. You are the subject matter.
Well, I had dropped out for some reason. Well, carbon fiber composites is a very fast growing. The problem with that is right now a lot of the bigger players and the players who are investing a lot of money are not putting money into it because the high value applications are metal still. I mean, I give you an example. A grid fin, just a grid fin for a space launcher, and they have 4 on each rocket, and you're going to have 25,000 rockets launching off over the next 10 years. Each grid fin in titanium, end use cost today is about $100,000, and 3D printing will reduce it to 25,000 to 30,000. So that's where the money is. Launchers, the fuel tanks, from $80,000 to $10,000 in cost. The other problem with carbon fiber composite adoption today is it is not so useful in combustion or in defense aviation. It's not so. They have applications, but not so many. And so people are focusing on low-hanging fruit right now. Marine and maritime, carbon fiber is huge. And also for energy generation, windmill blades, it is huge. So people are working on it. A lot of those are prototypes with a large, windmill blade. I mean, it's 30 meters long. So there is some time to get there, but people have printed it. It's just that it's not cost effective today. I would say that carbon fiber reinforced metallic structures are going to become very popular. There are 4 or 5 startups in the US right now with carbon fiber reinforcement and also, titanium fiber, tungsten carbide fiber. So fiber reinforcements in full structures is becoming very popular, but it will take another 10 years before it becomes a reality. That is all I can say right now. I'm not an expert in that field.
Yeah. So for your question, Wing Commander
One
Supuri,
supplementary
there
question,
is
because I
yeah.
will be difficult to get him. Sir, for the world moving towards the electric vehicle market now, do you see in a foreseeable near future the guys who are getting into the electric vehicle EV market, you will have some machines or engineering proposals to print the entire electric vehicle car in one machine itself?
Is that
There
for
was
me
a
again?
slide on there was a slide on submarines being printed 3D.
Yes. Okay. Good. Good. So that's a great question. First of all, let me tell you that the key companies in electrical vehicles that includes Tesla, now GM, Ford, Volkswagen, and in India, Mahindra. I'm very involved with that to some extent. They are using 3D printing to lightweight the components. Because electrical vehicle, there are two things you have to worry about. Fundamental worries, not the detail worries. The battery life and how long will the battery last, which means the weight of the vehicle. So right now the focus is on lightweighting components, including a lot of lattice structures in structural components of the vehicle and things like that. Batteries printing is not there yet, and I probably won't be alive by the time they probably print 3D printing vehicle batteries. Now, coming to fully 3D printed cars, I have a slide which I don't have on this presentation. It's a company called Zinger, Zinger, which has fully 3D printed a hypercar. Fully, meaning by fully, I would say 80% of the car is printed. That's a $2 million car. They have 3D printed it in collaboration with a couple of high-end. Divergent 3D is a company in California. That's a major advancement. It was only introduced as a practical item this year. Printing commodity, commercial, common man car, or even luxury car and fully 3D printed in electrical vehicles, I'm saying 20 years away. A lot of metal is needed. A lot of metal is involved. And printing that much metal for a company, for a car that could be sold in $30,000 or $50,000 is not practical today. It is just not practical. So some time is there, but the beginnings are already there with hypercars and supercars. They're adopting it. So sooner or later, it will come to passenger cars. That is my statement. But lightweighting is the key application right now, reducing the weight. That
Thank you,
is the
sir.
number one application
Thank
in
you, sir. Thank you.
electrical vehicles.
Over to Shibu.
Thank you, Ashok. Yeah, thank you so much, sir. Now, I have Commodore Niranjan Kaddavis, who is also the ex-CTO with Indian Navy. Commodore, any conclusions to make from this session, please? Thank you.
Right, morning and welcome. The presentation by Mr. Ashok Verma was very enriching, and he covered many aspects, right from utility of 3D printing, as well as what is currently the trends in manufacturing in medical as well as aerospace and aviation sector. Mainly repair of crankshafts has been taken up. This laser cladding is very interesting phenomena and technology which is available. As we see in marine, a lot of crankshafts do undergo reconditioning, and they have to be re-sleeved, or rather at times they have to be discarded, resulting in a lot of loss of this expensive material which can be reclaimed. Also on propeller shafts repair, which has been also done in the industry as well as elsewhere, from the literature also that is available. Hull valves, submarine valves, propeller manufacturing by laser deposition, Also, he mentioned about direct energy deposition, which is one of the latest technique and can be imbibed by the marine industry. A lot of machines which are available in the market, 7-axis machines which are available for 3D printing, although the costs are very exorbitant, and we have to see how one can get low cost machines because we have seen the utility over a period of time. How does it make any cost effective proposition for companies to use it on a regular basis? So return on investment would be the criteria for commercially viable, it being commercially viable. US Navy has been at the forefront with manufacturing of many submarine hull forms. In fact, in commercial, some 3D printed tugs are also there.
Yeah.
The main players, as we know, is space, aviation, and aerospace, and medical fields, which are at the forefront. Marine industry is lagging. Need to catch up. The growth prospects are very encouraging, and but the marine industry needs to factor in the prospects and make it viable. Mainly the challenges would be in the availability of the material and the complexity of the binders and the agents and the combination of metal, also coupled with the training of personnel. That would be a challenge so that it can take off. The market in India is very, very nascent, rather minuscule as compared with the world figures, as he had mentioned. And he has proposed a lot of way forward and policy reforms which needs to be done. And I got really enlightened with the kind of photographs and pictures that he showed us, and together the marine industry has a lot to gain. And Indian Navy has made a forefront in introducing of these technologies. They have 3D printing machines in the naval yard as well as in the naval aviation yards. To some extent, the exposure has been limited, but whatever parts which are obsolete, which are not available, are being utilized for making it and being shipped to the ships. And also there is a proposal to install a 3D printing machines on one of the tankers in near future.
Yes.
And with the induction of these technologies, which has happened about 10-15 years ago, slowly the utility is being understood. And also I think probably in future one can see the 3D printing labs being available in the aircraft carrier and also on tankers, which is the way forward, so that while tasking of our platforms to Indian Ocean region, definitely this will be a force multiplier. And whatever parts, in case they have any breakdown, rather than getting it shipped from the port where it is stored, ready-use items can be made on board in the aircraft carrier or in the tankers, should we have these printers installed on board. But order for one has already been given, that is what I'm aware. And the more involvement of the companies needs to be there, so that the input costs are brought down, so that it finds more utility, and complexities of material is also reduced. Otherwise, the shipyards and the ships, they need to get their machineries operational so fast that the advantages which are there, it may be lost because of these technicalities and issues. Thank you, Mr. Ashok Verma, for a nice and enriching presentation.
No, thank you very much for having me.
Thank you, Commodore Niranjan. I'm sure there'll be a lot of these discussions getting evolved even in the eventual, panel discussion. because that is the key for us to also take some recommendations going forward to share with the concerned authorities, and that's the intention. Because I also have one question posted by saying what should be the policy that need to be taken on an immediate basis if that is possible. If that is possible. So I think in the panel discussion we will have all those aspects covered. Thank you so much, Bodor Niranjan. And now we will go to the next session, which will be shared by an expert and a domain expert from the classification side, because I think each of these aspects needs to be also covered. So Dr. Shastri, DNV Norway, will be joining, and he'll be sharing his presentation in terms of how 3D technology is actually gaining some traction globally, and how they have been able to actively participate when it comes to accreditation and classification of these parts. Thank you so much, Doctor, for your insights, and I will personally want to thank him because it started too early in Norway. He's actually now from joining us from Norway. Thank you so much, Doctor, and please, sir. Thank you so much.
Thank you, Dr. Shibu, and to all the dignitaries in the panel. So it's my pleasure to be giving this talk and sharing our knowledge that we have been doing for several years. Yeah. So it's India is not our main market, but certainly this is interesting as my home country. So I'm happy to be here, and let me share things. Okay. Okay. Sorry. It went a bit fast. Yes. So before going into my talk, to just give you a brief introduction about me. I was graduated in metal in 1994, and then I joined BHEL Hardwar. And since there I worked in 3 places in India: BHEL and Reliance Petroleum, Jamnagar, and also and Council of Scientific and Industrial Research. And in 2000, I actually was invited by Belgian government to join them as a scientist. So 20 years ago, I moved to Belgium. From there, I was working actually, started working on European Union projects that actually we developed 3D printers and heavily materials development those days. So from there, I moved to Canada, continued to develop cold spray technology and other technologies for Chrysler and other companies. And in 2007, I came to Norway, joined as a material specialist, took over the materials for Maritime as a specialist and writing rules. I have been traveling around the world, meeting all the shipyards and also ship owners. And I've been teaching, training, and solving problems in maritime. 4 years ago, I was invited to go to Singapore. Actually, Singapore government wanted to do something in maritime 3D printing. So I was invited, and they have sponsored us to be there. And I'll share some more details about it. So I just returned to Norway after 4 years in Singapore, but I'm continuing with 3D printing. So as a material specialist, as a 3D printing subject matter expert, as a maritime expert, a lot to offer. But I think so. It's short time, so I will share something that the influence we have done personally from my side and as our company as an AAM adoption advocate. How did we influence this? And we want to be catalysts. We want to see things go in a nice order rather than becoming a chaotic situation and affect everybody. So that's what we are doing our things. So I will talk about a little bit about maritime and challenges and opportunities, because 3D printing and maritime are 2 different worlds. The machine suppliers, manufacturers, not necessarily know what is maritime, and vice versa. I'll talk a little bit that and so as a result, what stops AM adoption maritime? I'll talk about it, and what can promote adoption. That is what I call the rules of the game, and I will show some case study examples. Okay, so let me introduce DNV to those who is not familiar. Is a Norwegian-based global multinational company started 157 years ago. It's the world's largest and leading classification society. We have offices in more than 100 countries, and this is being a foundation. We heavily invest in research, 5% of R&D. For example, we are sponsoring PhD students, professors. I have 2 PhD students in 3D printing in Singapore, for example, and we have a lot of projects going on around the world. So we are in the ship and offshore classification. We are an energy advisor. We have digital solution provider. So let me set the importance why why to focus on maritime and 3D printing when you have so many problems. Yes, so maritime industry is the lifeblood of the global economy. Nobody can deny with that. It is responsible for the carriage of 90% of world trade, and with more than 50,000 merchant ships, and DNB have more than, I think so, almost we have more than 20%, around 20% share, market share that fluctuates in this. So there are 150 nations and millions of people working in this one. So it's $1 trillion industry, and a lot of money is scattered everywhere. And in one way, if you see, maritime is a very, very traditional, very, very conservative industry. But if you just take shipbuilding alone or repair industry, it is $300 billion around the world. I've been visiting all the shipyards around the world, and I've closely seen that how they respond when there is a crisis and how they retract. How how can we help the maritime industry? This is what we continue to see apart from writing from rules. Okay, so the main challenge for maritime industry is increasing costs, whether it is building or operating. Even though there is of course there are cycles of good and bad times for maritime, and we know that what some years we have 600 ships are built, sometimes only 50 ships are built. I've been traveling to China, for example, between 2008 to 2012 or something, when China was making so many ships. How the technology leap has happened. There were some golden times, and suddenly something has happened. So the same thing. If you there are so many regulations. Every country try to put those regulations. Yes, stricter regulations are also coming for the maintenance, and why DNV, why classification society is there. It is because to avoid the port state detentions, and but of course the goal is to maintain the safety at sea. So continue to face, this industry continue to face maintenance and other restrictions, and also the the sophisticated machinery actually giving problems to it is many things cannot be easily repaired. For example, a small small telephone holder in an emergency telephone in the captain's cabin is broken, and then they have to throw the whole unit just because of that. Now 3D printing can actually solve those things. That's a small example. Let's come to the subject a little later. Okay, so 3D printing and marine offshore have a lot of opportunities because everything is about materials. Everything is either structural materials or a maritime or a machinery material. So that is what actually 3D printing can do. Okay, the other question comes: can it be cost effective? We come back to that a little later. So the biggest advantages of additive manufacturing is ability to reduce lead times in part supply, and ability to store digital version of spare parts, and also reproduce obsolete parts, among so many other things. So now, what are the potential applications for maritime? Again, there are many, but let us take the biggest two segments: shipbuilding and ship operations. So structural parts can be fabricated. For example, some of the parts that are working in Singapore, Sembcorp Marine wanted to replace some of the notes that are imported from other countries like Korea or somewhere. These are like $100 million, or maybe $500 million, in a year, for $1 billion ship, and many more of those things, because they have to order 1 year, 2 years in advance. But we have shown that these can be made within 5 to 6 weeks. So remanufacturing and repair. Lot of shipyards have they say that, sorry, I cannot. We cannot wait for even a small machined shaft, because the ship has to go. So how 3D printing can actually start working, even ship is coming to the repair yard, and how it can actually be faster than many other supply chains. So we have proved it. So we wanted to influence. We are not in the business neither to make parts, not to sell parts or use parts. We are the regulatory authority, in a sense, from the technical sense, and we want the good quality to be maintained. So a lot can be spoken about the operation stage of ships. Digitalization of spare parts have a lot of advantage. We were working with Singapore government and Maritime Port Authority of Singapore, to show the benefits of 3D printing, and we took, the Singapore Shipping Association gave us 20 companies. They have shared us 1 million spare parts data that they were procuring for last ago, the time when we were doing, and we have shown that how many parts can be made in 3D printing if this industry becomes organized. So today it is a little bit of cowboys here and there are some of the organized people, but and a lot of people in the border waiting for things to happen. So yeah, now we see that yes, a lot of opportunities that 3D printing brings to the solve maritime issues, and it can help to reduce cost and more. So why to wait? Why we are not able to? Why this? Despite aerospace and medical and every industry has gained, why not maritime? Okay. So this is what actually the situation. 3D printing industry, printer makers are very powerful around the world, making so many hundreds of printers, thousands of varieties, and supplying everywhere. So when I was invited to Singapore in 2016 and 17, I surprised to see one of the most densest printers in the world. Singapore government spent like $300 million of printers, and when I met those government officials, one question, DNV to come here and help us to take all those parts made and put it in the showcase to the ships, to the offshore platforms, to the end user. So yeah. It is very tempting to the makers to make parts and actually to supply, but the ship owners cannot receive it. So what stops them? Yes, the regulations. Everything need to be checked and vetted, because it's a very complex industry. So you need guidelines, you need compliance, you need standards, you need rules. So are they there? No. Currently, I mean, I'm talking about 5-6 years ago. It is impossible to even think. So when I visited first time Keppel shipyard, addressing hundreds of their senior employees, and one employee told me, "Hey Shastri, you gave a very good, impressive talk about 1 hour, but even when we have a small welding problem, class society makes a big issue, and you are talking something 3D printing that you wanted us to use it." Yeah, but I said, yeah, now you wait for few years, and we see that actually how 3D printing has become more powerful, because of a lot of people started working on it, and actually it has a tremendous potential itself. So welding has not not because same advantage, because it is not a digital technology. So you can't get those white collar people entering into welding in a way that they could enter into 3D printing. So 3D printing has, despite having all those benefits, so why it is not entered into a great potential industry, maritime, is because maritime is the first international industry to adopt widely implemented international safety standards. These regulations prevent some stakeholders from cutting corners. Unfortunately, as a maritime material specialist, I was approving more than 2,000 manufacturers around the world that are actually, you can call this biggest steel plants or biggest forging companies around the world. And but down the line there are some manufacturers, they always take shortcuts. So that's what so we have to put same rule to everybody, whether it is a Nippon, it is Doosan or somebody. And unfortunately, we can't discriminate different manufacturers unless there are certain provisions. So rules always comes when there are accidents, etc. happen. So that's what maritime industry. What is very important is to get the approval. So ticket to the trade is very important. So 3D printing industry cannot just throw yes, they have a solution, they cannot throw. So these trade practices regulatory as simple as one can think. It's again, even if you know that, it's a quite a difficult path to find out. You need a lot of consultation, you need a lot of understanding, a lot of expertise even to understand. But yeah, it's not intentional, but these rules are made like that. But with this situation, how 3D printing industry, how it can reach to maritime and offshore giants, this is how they find. Okay, so they find a bypass. Okay, so that many parts that don't fall into the classification or regulations, these were made by many companies. This, and but the value is where in the classification and complex parts, and where that can solve the problems. So due to the complex nature, there are established trade practices, and unfortunately 3D printing companies cannot bypass those. So there are complex relations between owner, shipyards, manufacturers, and class, for example, and there are certain protocols, and flag state, port authorities, regulatories are quite taken into confidence. So now with the 3D printing, a manufacturer directly have to supply parts to the owner, bypassing most of the other things. Is it possible? Yeah, it was not possible few years ago, and nobody wanted to break this value chain that was established. I'll show you how we broke those barriers and started paving the way for 3D printing to reach ship owners. Okay, so this is how we did. So there is a trust pyramid in maritime, starting from IMO regulations to classification rules and maybe OEM rules and so many all those things. So DNB has dedicatedly focused on this technology. Because I did my PhD in this and worked for 20 years, separate 20 years ago on this technology, and continue to work with maritime manufacturing. Is almost 6-7 years ago, a lot of companies around the world and shipyards started asking me, and then the Singapore government contacted, because they host two of the world's biggest shipyards, Semcat Marine and Keppel. So I've been to Singapore, and I set up the Global AIM Technology Center of Excellence. So through that, we were advising, as a thought leader, we started joint industry projects. So the biggest adoption problem is the mindset. It's not about the technology. So how to influence people, how to influence the decision makers, and how to support So we have actually helped to spread the news that this is something, and Singapore have set up a national agency called National Additive Manufacturing Innovation Cluster. So when I went to first week in Singapore, the head of this NAMIC, National Additive Manufacturing Cluster, took me to the vice president of Semcat Marine, and we just talked almost 20 minutes, and this guy stand up and said that to Shastri, I'm okay. And we just agreed within 20 minutes for $1 million first project. And then the NAMIC head was saying me, Shastri, I was trying for last 2 years for almost 5 times, to bring them, and they didn't. But this is the company we want to trust. These people have to, this kind of trust works in maritime. So I started visiting many companies around the world and shipyards, and many people asked me, show me the full pathway. So I have made this pathway almost 6 years ago, and later I started writing the first guideline, first ever comprehensive guideline in additive manufacturing for a classification society. This is in a qualification and certification process. In 2017 that was released, and from then we have released many of those standards. As you can see, no other classification society have this many standards. I have been working with, for example, Singapore military forces. I was in the main committee there. We have released more than 3 standards for them. I've been advising and with the Defense Forces of Australia. So they asked me, seeing all these standards, they asked me to write their qualification and certification policy document and technical issues. We have finished it. We are working on taking it to the qualification of their parts, etc. So we have been working. I was based in Singapore, working around the globe. And writing standards, working with oil companies that are interested in this tanker business. And I have met more than 500 CEOs from all the shipping, or everybody have a digital goal. This we could actually do that in an influencing way, rather than just inventing few two parts or a few parts and introduce the technology. So the biggest thing you can do is influencing the decision makers that can actually influence the world. And so for example, I have introduced a methodology called joint industry projects to Singapore that time. So immediately Singapore Shipping Association, having 350 members, came and said that I can offer you 20 companies. So I just started a project. For example, you can see these companies. We couldn't, everybody wanted to join. We could not put everybody of them. So in this we have, as I said, looked into 1 million spare parts. For example, companies like Wärtsilä that supply parts, OEMs, so I could. Yeah, we did a big economic feasibility study. This is how we have shown what is the potential, highest potential, moderate potential, lowest potential parts. So this is just a model. Okay, so that everyone must do that. We have produced a comprehensive report, and this is published on Maritime Port Authority of Singapore's website. You can access. We have given recommendations to the government. Even we are so fortunate that most of the ministers of Singapore were visiting our center. The Deputy Prime Minister was Transport Minister and Deputy Prime Minister of Singapore. You could see them came when we were releasing the report, and talking to us about and they take it as their national priority. So just now I'll show some examples, because there are thousands of examples that we have helped companies around the world. We are working with more than 150 companies around the world. So just some examples. This is the one, from the repair ad of Samkaran. So when they shown that, some of the sleeves, for example, they're not worn out completely, and they have to throw the piece. So we said that why don't you cut? Sometimes it's only worn out for 10%, sometimes 60%, and if you grow that within an hour, and you cut 1 week time, if you want a sleep or whatever, for example. And of course, all these things is not from a scientific point of view, but it's a technical, and we are one of the strictest classification societies in terms of quality. If DNV approves, everyone else wanted to approve. This kind of a reputation we have. So a lot of metallurgical insights have been carried out. And of course, there are numerous parts that can be repaired in the ad, and now some countries mostly adopted this technology. So I have talked, many shipyards, whether it is a Hyundai or it is many shipyards around it, whether it's Astal in Australia. So all try to adopt this technology to whatever. There is something, yeah. Yeah, so the again, we try to influence, and we wanted to inspire the companies. Our CEO was handing out the first part certification, because anything you do, everybody is asking what is next step. When parts can be made, people said, "Hey, can you really? DNV can dare to certify it?" Yes, here you go. So we have certified the part and shown, because in maritime, certification is a big deal, and this is a big breakthrough. So our CEO was handing over the first ever certified part to the CEO, the president of Samkat Marine, and one defense yard wanted to experiment, and they have a design engineers deployed, and we have made some part for them, recovery David. So a lot of success stories around the world. So Keppel Shipyard came to me, and we were working, and then so they were able to produce one of the largest. It's few meters long and few meters high, and it's around 1.5 ton. It took some time, but as you can see this in the red circles, this is how we do the quality control, or the testing, quality assurance, to certify this part. So when we certify this part, this is a very breakthrough. So again, I could show hundreds of examples, but that is not the issue here. So what I wanted to say is that there is a hierarchy, there is a trust pyramid, and when things are done in a proper way, and definitely this technology will be adopted by those who are in need. And as one of the panelists was saying, 3D printing costs will come down. It will become a commodity sooner or later. But what is important is to find out and use it as a when time is the enemy, for anybody, the technology is the friend. So where this technology can help them, and DNB is offering all those certification. Yeah, thank you. So yes, so. Finally, I wanted to say that this is how DNV is cleaning up the regulatory hurdles to those companies that wanted to enter, and give the maritime industry. And this is most, I think so, my last slide.
Sir, thank you very much. What a enlightened talk, and you have brought the worldwide and universal knowledge to the fold. We would like to invite you to visit India as soon as possible on your way back to Singapore or whenever time zones permit you. And which city are you right now? Are you in Norway or in Singapore now?
I'm in Oslo now. Yes.
Okay, so whenever you're flying over India, request to land at Indira Gandhi International Airport. We will receive you, garland you, and take you to Prime Minister of India's office for a felicitation ceremony from the office of Dr. Vasudeva, who's our distinguished fellow. At the end of the day, we'll have some surprise gifts for some of the panel speakers. So I'm sure we would be eager to know more about you and what a journey. I would say that something fantastic both the speakers till now have brought. It's people who are missing this session today are missing a gold mine of information. Thank you, Dr. Sastri, and over to Dr. John if he's around here. John, you are to unmute yourself.
Thank you, Dr. Shastri, for your insightful presentation, and also because it gives a larger perspective of what can be done in maritime, to the extent, because since you are in the epitome of classification and certification and also material science, it's a good combination, Doctor. Thank you so much for your presentation and a detailed, with the expertise that you could share. There is one question which has been posted by Mr. Ashok Verma, that what is the highest value 3D printed part in marine and maritime industry to date? In which material is what you feel with your research?
Okay, so value is not always with the money, but solving a problem, for example. So there is no very straightforward answer, but what I have seen is, for example, it was down, because of one critical part was missing. And when this was printed, and I forgot to tell, actually, I've been working big industries very closely. They all came to our center talking to us because they wanted to see that how 3D printing can actually help, bringing the equipment back. So otherwise they have to pay a lot of losses, every day. So directly, actually, we have seen $1 million were saved by few times, actually, by otherwise they had to wait for 6 weeks to 4 to 6 weeks, and 3D printing has come down into 3 days. So one interesting thing I can share, when I was in one of those meetings, suddenly my phone rang in Singapore, and I saw that one captain, one of the ship's captain, somebody was calling me from Bergen in Norway. I never know this actually. So when I attended that call, I cited that one ship in, I think it was 2018 or 19, grounded off coast of Norway, and so all their engines froze, and they have a main problem. They talked to Man Diesel, and Man Diesel told, we cannot give you those parts that are that can be given, that are important for you to for your engines to come back, and it could take actually 2 months. And so these people somehow came about to me, even though I'm not a maker of 3D printing. So they're asking me if I know somebody that can 3D print urgently some of those parts they need. So actually, I put them in touch with some of those people I know, and actually that problem was solved within 3 days. So value is always, of course, materials. We see that high exotic materials like titanium, etc., are used in turbochargers, etc. But the biggest value will come in future with the steels, normal steels, and of course the copper and the copper alloys for propellers, etc. By the way, I forgot to tell, now Singapore government has awarded the second phase of the funding for 3D printing. Now almost 15 projects are going on. DNV is leading two projects with almost 50 companies, with a lot of OEMs, and for example, we are replacing propeller blades, engine parts, and so many. And these are quite difficult to put in the money. But money is when you have an insurance claim. Actually, that's what I can say.
A country and which is actually a maritime nation. Technologies like that, having taken the first initiative and an advantage, is definitely going to be benefiting when it comes to shipbuilding and maritime going forward. And I also am aware that NAMIC is also one serious initiative formulated by the government of Singapore, which is National Additive Manufacturing Innovation Cluster. Now, this is a government body. So, Wing Commander Ramanji, this is something which is going to be of key interest for us to have formulated this committee that we are actually working forward, working with the PMO's office. I think it's very important that there has to be a strong body representing 3D printing in the country, because that's very, very important. I think that's something which will also engage our interest to have more, investor bodies, and also so just to update the viewers and the audience, that this is something that has been initiated at the helm of Wing Commander Raman Surupiji, and also with the privilege of us to have been able to get in accordance with Dr. S. Vasudevan sir, who is from the PMO's office for defense technology. So I think maritime warships, these are all going to be an active areas of interest for shipbuilding. Various parts can be of serious interest. So I think what do you think, Ramanji, should be the key for us? I think maritime and shipbuilding should also be taken seriously going forward. And
Absolutely. In fact, one question I've been asking since morning, it's in the back of mind. We are flooded with a lot of inquiries during the COVID time of last 12 to 18 months. Investors want to invest, and they say, how much is the investment required? Where should I invest this next, couple of dollars? So because the money is always limited, so I am asking the experts, may not be at this session separately, if an investor has money and he wants to get into 3D printing, who can guide me and who should take care of his funds with a 5-year perspective plan or a 10-year perspective plan? You remember the Indian telecom industry when it came, one call was costing about 15 to 20 rupees way back when they came, and the Motorola handset module used to be 15,000 bucks. Today you see the way the telecom industry is gone. You are actually not using mobile phone for making calls, you're using for data, for internet, everything else. So mobile has taken away the photography industry out of the business. So 3D printing, people are wanting to invest, but need some guide. There are a lot of people from Gujarat in India and many parts of remote villages. They say agriculture sector has a lot of applications. India is the agriculture economy. Imagine if I can have the Indian farmer's tractor printed. What will be the cost implications? And something which we cannot, forget about it. So I would request to bring all the stakeholders on a single platform, the education industry, the regulatory, certification, investors, and of course the business enterprise who need the funds. So we have investors, we have people willing to invest. We have to connect all the dots together, and whatever help required from the government, we'll definitely push the way forward into that. Over to you, Dr. Jan.
thank you, sir, for your inputs. And I think these are, respondents coming from various global perspective, and with their best practices would be a great, greatly, it will actually set a pathway for us, which also comes to a point wherein I would want to introduce our next speaker. He is Daniel Tan from Wilhelmsen Ship Repair. Now, Wilhelmsen is actually a company offering shipping services in the globe and based in Singapore. Also, with his best practices, offering services in 3D printing would be really interesting for us to know to the extent of work that they have been able to offer. Daniel Tan is the venture technology respondent for Wilhelmsen Ship Repair Company from Singapore, based in Singapore, and has a vast experience of maritime in his stint in terms of the opportunity that it holds. So, Dan, over to you. Thank you so much.
Thank you, Dr. John. Before I start, can I do a quick mic check. Am I coming clearly to yourselves? Is it okay?
You're on
Yes.
the screen and you just need to load in your presentation and we start.
Very nice, very nice. Thank you very much. So, yeah, pleasure to be here, and it's wonderful to be part of this discussion. I think we have made very fruitful insights so far, and it's nice to also see Sastri. Thanks. Nice to meet you again. We work very closely together. When Sastri was in Singapore, we were nearly in contact every day to explore 3D printing for maritime. So today, let me try to share a presentation with yourselves on what our 3D printing venture has been trying to achieve. Sorry about that. Let me adjust. Okay, I think you see my screen now. Okay. Yeah, so I'm Daniel, part of the 3D printing venture from Wilhelmsen and Thyssen Group. So Wilhelmsen is a well-established company in maritime. If you meet any seafarers, if you mention the name Wilhelmsen, it's likely that they would recognize us. And in this 3D printing venture, we work very closely with this engineering firm called Thyssen Group. In essence, we are trying to enable on-demand manufacturing of spare parts for the maritime industry. A bit about Wilhelmsen. Our strength is in ship management. So we operate vessels on behalf of vessel owners, covering end-to-end processes like port clearances, onboarding of deliveries, and all the way to providing the daily needs on board the vessel. For myself, I sit under Ship Service Marine Products, where there's a special arm called Open Innovation, led by Naku. And under Open Innovation, we explore new solutions for the maritime industry. So in my case, it is 3D printing for spare parts supply. Wilhelmsen as a whole, we also provide government services for logistics of government assets. We operate roll-on, roll-off vessels through Wallenius Wilhelmsen, and we also have other R&D interests, such as providing platforms through Doolittle web services, exploring autonomous vessels through our collaboration with Kongsberg in Masterly. So we do have some R&D interests, and for us, we have served over 75,000 port calls in 2021, and we serve 50% of the global merchant fleet. In essence, whether it is ship management or providing marine products, we're in touch with 50% of the vessels out at sea. We are supported by a group of 3,500 marine professionals. And in this 3D printing venture specifically, we work off Singapore in collaboration with Thyssen Group. So we are based in the Thyssen Group office, and Thyssen Group as a whole is a conglomerate headquartered in Essen, supported by 104,000 employees and having 29 billion years of annual revenue. Thyssen Group's deep engineering expertise support the venture through its various capabilities. They are very wide. They look into automotive technologies, industrial plants, so they operate and manage cement plants. And they also have stakes in naval systems. So whether it's in submarines or surface vessels, there's some synergy here because some of the parts are common between commercial vessels and naval vessels. And their material services actually give us an avenue to supply some of the 3D printing materials that can be a bit unique and that we need. Yeah. So for today's presentation, I'll be glad to share the value proposition of our 3D printing venture. So as a venture, we are essentially exploring. We are essentially scouts. We go out and see whether a certain technology or solution provides the value to, in this case, is 3D printing for maritime. I'll also highlight some of the progress we have so far and the interesting use cases. Value proposition. In essence, we're providing on-demand spare parts to maritime end users. So some of these end users are essentially vessel operators. These vessels can last for 30 to 35 years out at sea, and it's common during these times that some of their suppliers go out of business or new suppliers come in. So you can imagine that discontinuity would cause certain problems for the onboard system. If, let's say, a spare part is missing from a legacy system, does this mean that they need to spend thousands of dollars to replace whole systems and even overhaul systems on board the vessel? Through our service, this can be mitigated by providing spare parts for the system rather than changing whole systems. And it is not uncommon that certain parts suffer from long lead times, be it 4 to 6 months of delivery. And through our on-demand service, we can produce it. I mean, yourselves being practitioners in the maritime industry, you will know that spare parts can be difficult to get sometimes. And through 3D printing, we can supply this in 2 to 3 days. Yeah. Some of the parts suffer from poor part performance. Everything is very metallic, and yet there are advances in materials that can help to value add to vessel operations. And for our OEMs, which is a very special group of partners that we work with, they have difficulty storing legacy spare parts in warehouses. They could, of course, produce this, store this in their warehouse, but they might never ever be used. So it's both not an economical and ecological solution. Through our on-demand service, they only need to store their designs with us, and we can produce it on demand for them. And we are very clear in our service, we cannot compete with traditional manufacturing. So things that are easily off the shelf are difficult for us to compete with, because generally 3D printed parts are more expensive than parts that are produced, example, through casting. In our venture, we work on an ecosystem approach. So we know that even though we're Wilhelmsen Thyssen Group, having the logistical and engineering know-how is not enough. So we tap on external partners, in fact, global partners. We have good manufacturing partners in India as well that we work very closely with to produce spare parts. And for classification societies, we work mainly with DNV. So our links with Sastry is actually very strong. Our OEM partners and end users also work together, and we know that this is a new solution. There is never a first-time success. It's a journey. So we are very grateful for our end users who are very forward-thinking and willing to try new 3D printed parts on board their vessels. It is both an education process and getting across the hurdle that 3D printed parts are not as good as traditional parts. Sometimes in the case, it could be, but with the right quality assurance procedures, we can overcome this. So in essence, our model is that if a need arises on board a vessel, the end user only need to produce engineering drawings or pictures of the parts and send it to our engineering team for re-engineering. And following that, we'll go through local production. So for example, if a part is requested in India, we will look for a manufacturing partner who is based there to produce the parts for us, so that we save on physical delivery, lead time, and cost. We work across a range of technology solutions that you can see on the screen here. And there are various parts that we look into, be it small metal, polymer, rubbery parts, or your medium-sized ones could be about 30 cm in diameters, even large parts, 1 meter in size. These are within our scope, and we work with our global fabrication partners to produce them. Okay, this is an interesting slide because with IMO, International Maritime Organization, there is a certain focus for carbon reduction and for sustainability. So through 3D printing, we want to enable this. We want to be a key sort of provider of this solution. We look at reducing physical transportation of parts. So send digital files, not physical parts, which saves on carbon footprint. We use additive manufacturing versus subtractive, which saves on raw materials. And we try to enable a circular economy. We have been trying to explore upcycling 3D printing materials, such as metals through atomization procedures, or polymers, even polymers, that could be reused and given a new lease of life through technologies like SLM or FDM. Our procedures for completing orders are guided by a ASTM 52901 standard, and this is endorsed by DNV. This is our quality framework. When we started off, we knew that we need some guidance, and we followed these standards, which translated to sort of operational checklists. So at every step of the way, be it getting the design requirements from end users or sending the data package to our fabrication partners, all these are guided by forms and checklists to make sure that we have everything in place to produce the final part with fitness for purpose in mind. And all these documentations are facilitated by our digital platform. So our digital platform is developed in collaboration with ThyssenKrupp Innovations or the ThyssenKrupp Tech Center based in India. And this is sort of, I would say, the heart of our operations. It essentially stores the digital files and then send these together with their requirements. With our global fabrication partner, it orchestrates all the deliveries and tracks them.
Sir, sorry for interruption.
Yes.
If I permit, who is your partner for digitization in India? I could miss the name.
We don't have a digitization partner, but we have a platform developer in India.
Okay. Who is the partner?
And that is ThyssenKrupp Tech Center. So
Which one?
It's an arm of ThyssenKrupp.
Which group? I'm not able to understand.
Let me. ThyssenKrupp. Yeah.
Okay, ThyssenKrupp. Okay, right. Thank you.
Yeah.
Please proceed.
No
Sorry for interruption.
No worries. Happy to share. Okay, so just to assure our OEMs, we also have defense-grade encryption decryption capability to protect the designs, which is the lifeblood of our OEM partners. Some highlights of our progress so far. I would say that our 3D printing venture, which is about 10 people within our venture now, is in a good position because manufacturing is progressing towards additive manufacturing in general. And a survey from Jabil that you see from this screen here shows that more and more manufacturers are looking into 3D printing as a solution. In 2017, in green, there are very few parts that are used for 3D printing, but manufacturers are slowly increasing the percentage of parts that are actually manufactured through 3D printing. And some of the qualities that they look at to partner a 3D printing bureau or a service provider like us is their design capabilities, ability to scale, and pricing. So all these factors, we think that we have captured them, and we try to provide them as our focus towards our end users. With this in mind, we have set out two programs, the Early Adopter Program and the Fast Forward Program, with a total of 16 different partners, end user partners, and within themselves, they command about 3,500 vessels. And all these vessels require spare parts. So we have been providing spare parts to all these vessels, and in relation to our collaboration with ThyssenKrupp, it's getting closer and closer. In fact, for myself, I'm based in Singapore, but I go to the ThyssenKrupp office all the time. And we would be announcing something towards as the year goes along in terms of our joint venture. Our OEM partners have also given us good feedback. They do see some potential. For example, with Kawasaki Heavy Industry, their focus is on enabling quick turnaround of spare parts through AM. And we have been discussing with them about creating production pipelines in parts of the world that they want focus in. So things have been going well, and they do see potential in us in being a steady state provider of their spare parts going forward. So Kawasaki, Wärtsilä, and some of our end user customers also feel that this is the potential for spare parts in the future. So for now, they do understand that it's an exploratory stage. We need to work together. We need to understand 3D printed parts better. It's an education process. It's a journey. So we have been providing spare parts, and they have been wonderful end users. As practitioners in 3D printing, we do know that it's never so simple. 3D printed part, when you submit to a vessel, might not work straight away. it might take some iterations, and it involves good end user cooperation to make this work. So we are very glad for our 16 end user customers currently. And these are some of the feedback that we received, even for a simple, humble spider coupling part. We can now do this pretty quickly. In a matter of maybe half an hour, we can easily take in the measurements that is needed for the vessel, and then just 3D print them pretty swiftly. Yeah. Okay, use cases. I think this might be interesting for everyone. So we have been using 3D printing to supply spare parts through a range of technologies. The first one for the cooling water pipe connector. This is fabricated using SS316 stainless steel and fabricated through selective laser melting, essentially solving the pain points of long lead time. From maybe about 2 to 3 months, we can produce this in overnight. But of course, if you need to transport it, you will incur 2 more days, so maybe 3 days. Yeah. And with this propeller blade, Sastry mentioned this earlier as well. Propeller blade, typically it takes about months to produce, but through wire arc additive manufacturing, it can be produced maybe in about 2 to 3 days if all the parameters are in place, and also the sort of the specifications. So with Kawasaki, we are exploring this, and other things like the inert gas fan impeller have also been fabricated through wire arc AAM. So it's an interesting use case because for this, we provided a feedstock of a base material, and also building the wire arc AM process on it instead of producing the whole thing through WEM, which will be very expensive. So there are these sort of innovations that we have been exploring with 3D printing partners, and it's based on most cost-effective and lowest lead time approach. Some of the less critical parts that we see is like worm gear. So this actually is to support a system on board a vessel that if without, they will need to change the whole system. So by producing this worm gear through binder jetting solution, we save them thousands of dollars. And this fan impeller, typically made through aluminium, degrades quite swiftly on board a vessel. So when we saw this use case, the blades were all detached from the main body, and we knew that this was a critical component that needs to be reinforced. So through engineering and simulation, we have produced this part, and it's now made in carbon fiber nylon, which is in operation on board the vessel. We can also make flexible parts through FDM technology, and we can use corrosion-resistant materials such as hydro. A little bit deeper on the inert gas fan impeller, this is a large part, about 900 mm in diameter, made in SS316 and printed through WEM for lead time reduction. Another interesting use case whereby we substituted an aluminium fan blade with a carbon fiber nylon. So this could be a sort of a safety concern as well, because if let's say this fan blade breaks down or needs to be replaced frequently, it could be a bit dangerous depending on where this part is located. If it's on board, high up on the vessel, people need to climb up. Of course, there are good safety protocols in place, but I mean to save operational efficiency, we also produce this part through polymer so that it's more maintainable. Some of the other parts that we look into are valves with this OEM called Valan, based in Italy. And ThyssenKrupp itself also have some catalog of parts. This is a hydraulic valve block optimized for the SLM process. Some low criticality components, be it TPU, impellers, onboard pumps, some aircon ducting, or the humble but very important gaskets or O-rings. So there was an example earlier that the gasket, even though it's a rather humble part, if without on board the vessel, it can lead to operational problems. And we do encounter situations whereby OEMs discontinue producing such gaskets. And what we essentially did, because our 3D printing service is not a grey market, we went back to the OEM to ask them whether we can come to an arrangement to produce these gaskets on their behalf. So we didn't really take the design and run by ourselves, but we went back to the OEM to seek permission. Other examples for casting housing. So rapid casting, we are very interested in this solution. So if there are any rapid casting companies out there, yes, we'll be happy to work with them. It uses binder jetting to produce the external housing, which is 3D printed and then conventionally casted by pouring metal within. So this is a sort of a hybrid traditional 3D printing approach to produce spare parts. Fan blade, this is an interesting use case. It's actually received an urgent need for this order on a Friday. And over the weekend, Saturday, Sunday, we actually did the engineering and printed the part, supplied it on board the vessel. Yeah, so it's now operating on board a vessel. Impellers, this is also a rapid casted part. The quality of the part is excellent, and we think it can rival that of a traditionally casted impeller. This is what I have to share. I do have a video showing some of the more advanced technology solutions that we have. Essentially tries to prove the concept of a better logistic supply through the use of drones. This would be in the future. I mean, current state, there isn't this concept available now, but we need to start working on it now so that, to pave the way for the future. That's all for my presentation. Thank you very much.
Sir, small question, if you permit.
Yes, please.
In this video, you mentioned about using the drone to deliver the items from ship to shore and vice versa also. Now, I am reading articles that a lot of 3D printing technology being used for creating drone parts also. What is your experience? Are you looking at the use of your solutions for drone technologies? Or how much of drone components can be made into the 3D printed parts?
Yeah, so you are correct. A lot of the drone parts actually will be suited for 3D printing, mainly through FDM technology, essentially using polymer wires to print the part layer by layer. The application wise, it could be things like your propeller blades for the drones or the landing legs, and usually all these drones are quite bespoke. So unique. So with this drone that you see here, it needs to have a payload, and depending on the size of payload, the structure that is connected to the drone would differ, and that's where 3D printing can provide that customization. But we were quite deliberate when we set up our 3D printing venture that we will only concentrate on maritime. Yeah, so drone is not something that we supply very intensively. But maybe in the future, if it supports, the maritime industry, then we would start to produce parts for such drones. Yes.
The Indian government has eased the policy of drone usage into a lot of civil and military applications. So it's a huge market, and I would like you to look at this. And then we have some partners wanting to work with you for use of your technology for drone industry. and this could be a big money spinner for you also. So when you are having time, please connect with us, and we will give you the business opportunities. And Indian government is now working into a policy of more and more use of drones, and that is where the big buck is lying about. Of course, choice is yours, but this is industry which you cannot refuse to get. Thank you.
We agree. We agree. Yeah, and I would say that ThyssenKrupp, which looks into defense systems, will also be pretty interested in such opportunities, and they do have an AM arm, additive manufacturing arm, that can study into this. Yeah.
Next
So
time you are
yeah,
in Bangalore, please give us a call. We will receive you. Thank you.
thank you very much. Thank you
My
very
Yeah,
much.
pleasure.
Daniel, can I ask a small question, please?
Yes, please. Yes, please.
Since you have a center in India, Bangalore, was there any on-demand spare part request by Indian Navy, dockyard, or anywhere for manufacturing of these are very routine and critical components like impellers, like gaskets, like O-rings, etc. And the second part is the Navy may not have a 3D design of that particular part. They may just have a 2D drawing at the most. And from 2D drawing or a picture, how do you convert it to 3D model and then produce it?
Yeah, so we are supported by a team of engineers, and it's very common. It's actually very common for us to receive pictures
Yeah,
with a hand sketch measurements,
right.
and that is a good start. So from there, what our engineering team would do is to CAD it out, to design it out as much as possible, and from there highlight the other other measurements that need to be provided. It is also a part of a process, I would say. So if let's say the end user, they are more used to working with us in providing all these drawings, sooner or later they'll know what sort of measurements we need in place to do the 3D printing. Yeah. So in GIS, we're very used to this mode of operation. Yeah.
So once you do the design, it has to go back to user for confirmation naturally, whether the
Yes.
part is correct dimension, etc. Or a
Yeah.
rapid prototype has to go there for acceptability.
Yeah. The best case is if the end user can pass us a sample, and our engineering team can actually do the 3D scanning or do the CAD modeling and
Yeah,
measurement.
but
So that's the best.
sample may be worn out item and may not be the correct dimension which is required in the system.
Yeah. So you're absolutely correct. Yeah. So
Right,
in that case, pictures within the system is good enough. We can work with that.
right. Okay. I think your center should get in touch with the naval dockyards in Bombay and Vizag, particularly because they require these items, whatever you have shown in your presentation, on almost daily basis. Right. Thank
Yes.
you.
Yes. Thank you.
Daniel, I have a couple of questions. I'm Commodore AJ Singh here. I put it in the question box also. Firstly, does your partnership with ThyssenKrupp also include an arrangement with the Republic of Singapore Navy to provide 3D spare support for their submarines, which have been built and supplied by TKMS?
Yeah.
And
So
from that, how is RSN? RSN is a very progressive navy. Are they going in for 3D spare part manufacture in a big way?
It touches a bit on the classified information, but essentially,
No, broadly speaking, very routine
yeah,
parts. I'm not talking
we,
of
we, we are
high-end.
yeah, we are working together. We are working together to look at certain parts, and we are sort of starting slow to look at parts that are not so critical. Get AM on board, get AM parts on board the vessel first, and observe how it works out with the traditional manufactured parts. And then it's a progressive journey whereby we work on more and more critical parts going forward. Yeah.
But in the case of warships, particularly submarines, most of the parts have to meet very stringent mil specs. So how does 3D manufacturing adapt to that sort of high-end level of tolerances or just sheer resilience of the part which is required? It's not a routine COTS equipment.
Yeah.
And does that then come into conflict with your OEMs from whom you source your designs for various spares which you're doing 3D in? Do you have issues with IP? How does IP transfer work? I mean, are these issues also a cause of concern, or is it a very smooth process?
For your first question, right, we would never supply a part that we know is operating in a critical system without certification. So we've been very much in touch with the local classification societies like DNV to go through the certification and safety process. So DNV is very forward thinking. They do have procedures already laid out. Low critical, medium critical, high critical parts, all these have different procedures when do the testing, the physical testing, tensile testing, choppy testing, etc. For your second question on IP, right? We were very clear when we set out that we will not be a gray market. So if we do see a part that is OEM, that is IP sensitive, that is a bespoke or unique design, we would surely go back to the OEM and to ask them, can we cut an agreement in terms of fabrication, post fabrication profit sharing, for example. Yeah, and then we come with a formal arrangement before we fabricate the part. We
So
do have encountered.
They don't feel threatened. They don't feel threatened that here's a cheaper alternative to their, the part that they will offer.
Yeah, it really depends on how we position ourselves. So, if we set ourselves, as we can produce cheaper than you, you are in threat, then, things will not go well. And yeah, I mean, for us, we represent two established companies, so we need to be very clear that we do not infringe any IP. Yeah.
Oh, just for your information, by the way, I happen to be a senior vice president of TKMS India, so that's why the question.
Yeah, we are colleagues. Nice to meet you. Thank you.
Pleasure. Thank you so much. Thank you so much for that. Thank you.
Thank you.
A detailed analogy and also your expression with your presentation in terms of the services that you actually offer, more like an end-to-end with various different materials that you're dealing into today. So I think it's a good learning, and thanks for your question, sir, Kubodor Jitendra. I think these inputs and questions needs to be also addressed as we progress, and which is already being there in the domain that with the experts who are already doing it. So thank you so much, Daniel, for your insights, more in terms of your perspective and your presentation. Use Anthony Paul. Anthony Paul is a key respondent from L&T Defense, and he is also responsible for indigenously also offering services from India. They are setting up their hub, and he's the head additive manufacturing. He's the head additive manufacturing for Center of Excellence in L&T. Of course, they have a very large and a vast area of offering services across the domain. But yeah, shipbuilding also happens to be one area that they would want to explore. And with 3D printing coming into the space, I'm sure, Anthony, there is much to offer in terms of what you have already set your plans. And so welcome on board, and appreciate you taking to us through a presentation in terms of what you have envisaged and what is the potential, and how this center is going to be offering solutions to the end users in the country, coming from various different backgrounds. Thank you so much.
Thank you, Dr. John, for this opportunity. Warm greetings to all the dignitaries present, all the guests, speakers, and the various participants of the workshop. I will be sharing my screen, and I hope my audio is clear. Am I audible, Dr. John?
You're very well audible, Anthony. And your screen, you need to take it through in the main center, as in I can see the other slides on the left. Yeah, perfect.
Okay. Good morning, everybody. So my discussion today is on metal additive manufacturing, a game changer for maritime and shipbuilding. My name is Anthony. As Dr. John mentioned, I lead the Additive Manufacturing Center of Excellence at L&T Defense. Larsen & Toubro is one of the largest engineering, manufacturing, and technology companies of India. We have a wide spectrum of businesses that we operate in, coming from construction, hydrocarbon engineering, realty, power, heavy engineering, defense, IT sector, etc. We also cover defense shipbuilding. We are a professionally managed company. We have been established since 1938. We have group revenues approximating around $20 billion US. And we have a credit rating of AAA stable. Most of you would know L&T as the company making one of the largest, the biggest, the first, the greatest equipment and infrastructure in India and globally. So as you can see in this particular slide, the various products from our portfolios that we have. L&T Defense is an independent company under Larsen & Toubro Limited group of companies. Our product portfolios include guns, missiles, and armored systems, which are the top 4 products that you see, including aerospace sector. We have weapon and engineering systems, both land-based naval systems. We have military communication. We also have a dedicated shipbuilding and submarines and underwater platforms that we cater to. And hence, as Dr. John mentioned, our interest to be part of this August forum and also to indulge into additive manufacturing stems from our participation in these particular domains. We are an end-to-end solution provider. We work right from design, both in-house design and design to customer specification. We manufacture, assemble, test, and deliver these components and ensure that they meet all the requirements of our customers. So L&T Defense does the entire gamut of services, right from design and detail engineering, prototyping, production, precision manufacturing. And our precision manufacturing covers critical machining, sheet metal, heat treatment, surface treatment, etc., and the various joining requirements. We also have a dedicated composite manufacturing in-house. So we have an advanced composite center of excellence, as Wing Commander Sopori had mentioned earlier. Composites in maritime and shipbuilding is also starting to make a big impression. And we are already in that, and we are already addressing some of the composite requirements for the Navy, be it sonar domes, helodecks, and other components that are required. We all do global sourcing. We do assembly and integration testing. We do complete project management on a turnkey basis. And we also undertake trials and life cycle support. In addition to all this, we have recently gotten into metal additive manufacturing. So the objective of doing this was to have all the capabilities in-house and under one roof so that we can ensure the maximum quality, confidentiality, and security of our designs, and to offer maximum value to our customers. So why have we gotten into metal additive manufacturing? It's for 2 reasons. One, it has multiple design benefits. We're able to create complex geometries with minimum tooling requirement and features which we're not able to achieve through conventional manufacturing. And with this, we are able to introduce high level of performance optimization, making unibody components with a lot of part consolidation, lightweighting, performance optimization by just changing the geometry, etc. And we are also able to create multi-material parts instead of joining them through assembly and other processes. We also see metal additive manufacturing offering a lot of supply chain benefits. One is the flexible and efficient production, which also means a shorter lead time, which will be crucial for a lot of our customers who are on stringent timelines. We are able to make many parts of one type, or we are able to make one part each of many different varieties in the same machine at the same time. And with certain technologies, we are also able to offer repair and feature addition. So it allows us to evolve our design as we go forward and we find certain inputs and feedback that our design needs to improve. So we can actually do that. And this also helps to keep the development costs to the lowest possible. We believe metal additive manufacturing is very crucial and it's well aligned for aerospace, defense, and maritime because we are able to utilize it cost effectively for small volumes instead of large bulk produced and mass produced items. And we're also able to use it effectively for parts having high complexity. We are not professing that this should replace all conventional manufacturing. In fact, we are saying that additive manufacturing will complement conventional manufacturing. And this is why we have also gotten into additive manufacturing in addition to the conventional manufacturing and capabilities that we presently have. Of course, there are some constraints to metal additive manufacturing depending on the technology, the materials, the process followed, and also the controls that you put in place. It could be limitations in terms of materials available. It could be limitations in terms of size or complexity. You can have a very big part, but then the complexity comes down to some extent. Or we can have a very complex part, but then you're limited by the volume, build volume that you can build in. And in certain cases and processes, you have porosity, warpage, surface roughness, etc., which require good control and good process improvement. And in most cases, we find that there is a good amount of post-processing, be it heat treatment, surface treatment, or machining, which L&T is already equipped to do right now. We also have some level of mechanical properties that we need to ensure are not impacting the performance of the part, such as anisotropy, fatigue life, etc. And lastly, we also have to make sure that the cost of the part and the return on investment is worthwhile. So these are some considerations and constraints in additive manufacturing, which all of us are aware of, and we control this effectively at our own end. While there are multiple technologies under the AM umbrella, starting from vat photopolymerization, fuse deposition modeling, material jetting, etc., L&T's focus is on metal additive manufacturing, and we are looking at both powder bed fusion and direct energy deposition. In powder bed fusion, we are looking at both laser-based powder bed fusion, which is DMLM or SLM, and we are also looking at electron beam melting, EBM, both of which allow us to make smaller parts relatively, which are having high level of complexity and able to introduce many features such as lattices, etc. We are also looking at direct energy deposition with wire because we believe this allows us to get a lot of new materials and a wider spectrum of materials, and also because we have an in-house expertise in welding technology, which we hope to leverage for these technologies. One of this is wire rack additive manufacturing, which we are presently already into. The other one that is showcased here is the electron beam additive manufacturing, EBAM, which is something that L&T is also pursuing. Of course, in addition to this, there are also other direct energy deposition technologies which have powder as a feedstock. This could be lens or laser metal deposition, and this also covers the kinetic fusion or laser cladding technologies. These are technologies we are interested in, but at the moment we are not pursuing in L&T. While we look at all these technologies which are readily available and having very high maturity, both globally and in India, we found that each technology brings with it certain strengths and certain limitations. So if you look at the spiral chart, we can see that some technologies such as powder bed fusion are suitable for parts having high level of complexity, accuracy, and requiring surface finish without post-processing. Whereas DED technologies, including VAM, EBAM, and even powder DED, would be suitable for parts having larger volume, probably requiring higher build rates, and having more material flexibility. So therefore, we have taken a conscious decision to look at multiple metal AM technologies at L&T. And if you look at this particular chart by Roland Berger, where we have categorized the various metal AM technologies under part performance, cost, and lot size criteria, we believe powder bed fusion is something that will be necessary for high precision parts and smaller in size parts, and which will be well suited for aerospace and defense and also in maritime sector for metals. So we are definitely procuring these machines, and they are in the process of being integrated at our Additive Manufacturing Center of Excellence. We also believe that this alone will not fulfill the requirement, especially for the larger parts, which may have slightly smaller complexity, but which cannot be bound by the build envelopes of powder bed fusion machines. Therefore, we are developing DED with wire rack additive manufacturing and EBAM. So wire rack additive manufacturing is something that we do currently at multiple centers at L&T, both at our Hazira plant, at our Talegaon plant, and our Coimbatore facility. We do this with MIG, TIG, and we are also getting into cold metal transfer. We are also looking at developing DED wire through EBAM process in-house in collaboration with academia. So this is something that is in the works, and we are working on the same. So as and when we have the capability, we will be announcing the same and working with our partners and customers on this particular technology. So what L&T has done is we have established an additive manufacturing center of excellence. This leverages the existing capabilities that we have, which is end-to-end design, optimization, and engineering. We have extensive capabilities and facilities for post-processing, which is heat treatment, surface treatment, and machining, largely centered at our Coimbatore premises for precision manufacturing and at our Hazira and Talegaon premises for the larger scale components. We also have extensive capabilities for testing and qualification, both in-house and through our partners. So what we are adding to that is we are adding an in-house AM facility. So we have a center of excellence established at Coimbatore, which will be housing multiple metal AM technologies. We also have the capabilities added for design for additive manufacturing. We will shortly be having AM material characterization and handling. Some of the materials require specialized handling. We will also be covering AM material and parameter development because a lot of our customers require bespoke materials and niche materials which are not available presently. So with all these capabilities, we have not made much headway compared to most of the other speakers so far and those who would be coming thereafter. But we would like to stress upon the opportunities that we can address jointly with the various customers and various partners that we have. So covering few of the AM applications in maritime and shipbuilding, we have probably 3 baskets we are looking at. One is polymer based, which can be small components. In fact, L&T has done some of these water jet components. These are in-house designed water jet systems where we have realized these components for validation, both visual verification and for testing. And we have taken it forward from there, and it's installed in some of our petrol vessels, etc. It can also be used for making much larger parts and systems, such as the swimmer delivery vehicle or the seal delivery vehicle that is shown over here. However, as I mentioned, L&T is not pursuing polymer-based additive manufacturing at this moment. Therefore, these kind of components and technologies are subcontracted to our service partners. Another approach that we can do for metal parts is through indirect metal, which is creating parts through FDM or SLA and thereafter going through investment casting. So you can actually make parts very cost effectively with this route for certain components which are traditionally done through casting or investment casting. Our primary focus is going to be on direct metal, both powder bed fusion and DED. You can see in this picture on the side certain components such as valve bodies, trainers, etc., which are presently being done through metal additive manufacturing, powder bed fusion, and some other components such as complex and high performance propellers, which will benefit from the AM capabilities. Though these are presently done from CNC machining, additive manufacturing will enable these geometries to be constructed with minimum tooling and machining steps and material wastage. And I understand navies across the globe are actually pursuing metal additive manufacturing for various components for shipboard spares. Whether it's done onshore or offshore, that capability and of the technology is definitely seen and it's been pursued. I would like to stress upon wire arc additive manufacturing application in the subsequent slides because the laser cladding examples have been covered before. I believe the speakers in the second half will definitely cover the powder bed fusion approaches. So in the following slides, I'm going to showcase some of the use cases for wire arc additive manufacturing. And also because this is something that L&T has already established, and we have delivered a lot of parts for land-based applications through wire arc additive manufacturing. We are working with aerospace customers for the same, for aerospace application, and we are looking forward to work with our esteemed partners and clients for maritime and shipbuilding as well. So the most prominent example of wire arc additive manufacturing is the Vampeller, which has been developed by Ramlab, Promarine, Autodesk, and the Diamond Shipyard. So this is for a 16-ton tugboat where the propeller, the single propeller, has been done through wire arc additive manufacturing. They have showcased some of the capabilities such as hollow structure, which could be done through wire arc additive manufacturing. This propeller, I understand, has been certified by Bureau Veritas, and it is presently being considered for end use. But this is not a one-off case. There are other applications of propellers done through wire arc additive manufacturing. So this is by the Naval Group and Ecole Centrale Nantes, also with their subdivision Sirena. This too has been certified by Bureau Veritas. They have 2 examples which are showcased in this slide. One is the container ship propeller, which is having an approximate 6-meter diameter. The blade that is shown is a 1:3 scale, and I believe they have also done a 1:1 scaled blade thereafter. It's a 300 kg blade made out of stainless steel and printed in 100 hours. Similarly, they have an Andromeda mine hunter propeller, which is a 52-meter class boat with a diameter 2.5 meter with 5 blades. So these are unique blades, not a single piece blade, with the total weight of the propeller being 1 ton, with each blade coming close to 220 kgs. This is from aluminum copper alloy, and they have showcased better productivity, reduced weight, and acoustic discussion, which is necessary for stealth applications, and higher thrust efficiency with this process. So why I'm showcasing this is, though powder bed fusion and other technologies can probably give you better surface finish, wire arc additive manufacturing has been used and has been certified for use in maritime application with subsequent post-processing. And this could become a very cost-effective approach because we are able to leverage existing welding equipment and setup with certain tweaks and improvements done for the capability augmentation. And it's not only in propellers. There's another example of a Panama chuck which has been done, which is a 1.4 ton Panama chuck, which is done by ER70S6 wire feedstock. This has been undertaken by Keppel Technologies and Innovation, ALM 3D, and DNV. I believe Dr. Kandukuri could probably chip in on that in the later stage. So this is done by DNV GL, the Technology Center of Excellence at Singapore. A recent application is a 350-ton crane hook, which is done through wire arc additive manufacturing. This is 350-ton rating. It's a 1.7 ton with 1.7 meter by 1.3 meter size. It's made out of high-grade tensile steel with wire feedstock. It's done by Huisman, Czech Republic, and again tested and certified by Lloyd's Register. So this is a crane application, so which could also be used for maritime and shipbuilding considerations. One more example, it's a hybrid solution. It's not purely wire arc additive manufacturing. It's a pipeline clamp, which is done through DED hybrid, where some components are pre-machined and wire arc additive features are added onto thereafter. This is done by MX3D under EU Horizon program. BWI, this is Belgian testing agency, has done the material testing, and Lloyd's Register has done the process qualification. And this has been tested for test pressure of up to 60 bar. So this is useful in pipeline applications and would see a lot of similar use in maritime and shipbuilding. Of course, this is not VAM, but there has been some news articles about a contract by US Navy for MELD technology. This is another type of metal additive manufacturing where you're having cold process. A 1.5 million contract has been done, and this is for procuring MELD equipment. And the objective is to undertake ship repair, even for ship structure parts, such as a ship stem bar. Okay, so which tells us the direction in which metal additive manufacturing is going. It is not small parts and polymer parts. We are looking at large-scale metal additive manufacturing through VAM, through wire DED, through powder DED, etc., and through technologies such as MELD. So I would like to conclude that additive manufacturing has unshackled the designer and the manufacturer in defining what is possible. Additive manufacturing provides greater design flexibility and production agility. It allows us to optimize the performance. It lowers the development cost because it reduces tooling to a good extent and allows us to complete these processes at much faster rates. So it reduces lead time and inventory. And it also allows us to undertake repair and feature addition, which is critical to keep the overall operational costs of ships and maritime structures to the minimum. So in the recent past, maritime and shipbuilding sector has taken major strides, as I showcased in my previous slide, with a lot of components being verified and qualified for end use. And we also need to understand that we are not yet there where aerospace and defense sector is, and there is some ground to cover to reach the similar level of utilization. That said, multiple AM technologies are presently available both in India and globally, with each of them offering unique advantages and having certain constraints, be it dimension, be it material, be it the surface finish that is possible, or some of the mechanical properties. And at L&T, we believe force-fitting a component to AM or to a specific AM process is often counterproductive. So we need to identify if a part is suitable and feasible to additive manufacturing. And we need to understand which AM process, be it powder bed fusion, DED, or others, are appropriate for the particular application. And we also believe a diverse ecosystem with a broad spectrum of processes and associated technologies is essential in India to leverage AM and take it to its full capability in the years to come. With that, I would like to conclude my presentation. Thank you.
Thank you, Anthony. This is Raman Sapori. Can I ask a question?
Yes, please go ahead.
First of all, congratulations for excellent, I never knew L&T has done so much in 3D printing. I first have a suggestion for you. Indian Air Force has issued requirements for 3D printed parts. I'm not sure whether your team has addressed those. The list is already there on Air Force tender website also. 140 items are listed. This was announced in the last Aero India show also. You could tell your team to get in touch with the Air Force headquarters. The second was just a suggestion that your center of excellence, have you thought of creating a unicorn out of that? If you list your unicorn, your center of excellence of additive manufacturing, I'm sure that will become a separate business itself. So if I was you, I would have said, let additive manufacturing of the L&T Center of Excellence be a separate company by itself, I'll be the first man to put my first $1 billion investment into your company. It's a unicorn in the making. Yeah, thank you. All the best.
Thank you, sir, and thank you for the valuable inputs and your faith in us to deliver. We are definitely pursuing the opportunities in the aerospace sector, both within Indian Air Force and with our space sector partners.
The challenge is the certification organizations. As you know, in the Air Force, you have DGA QA, and in Navy, it is DGQA Navy. And then in the shipping also, we got IMO. So we have to educate the certification and validation authorities. While we have DNV and other organizations doing quite a lot of work, we need to have our own standards and practices, which will be part of the tendering authority itself. So with that, I hand you over to Dr. John. Thank you.
Thank you, sir. Thank you for your inputs.
Thank you, Anthony, for your detailed presentation and also setting up a center of excellence. And I'm sure there's a lot of requirements, and the gaps can be really filled in terms of the offerings. So morning we had various experts share about the technology and the potential that this technology has got, both from the technology side as well as the service side, with best practices, and also me sharing, in terms of the classification and material science. Now we will actually dwell upon the session 2, where experts and speakers will come from each of these companies offering solutions. So that will actually also help us to know the larger prospects that the technology has. The 3D technology per se would be actually shared. When it comes to the machine, the scanning solutions, reverse engineering not to be missed out. Also visualization and simulation is also going to be one of the aspects. And also proud to know that there are indigenously manufacturing companies manufacturing metal machines in the country. So that's a great breakthrough that we're seeing, that the pathway is well set for us. So thank you so much, and we will quickly go to the session 2.